Okay, today is Tuesday the 12th of March 2024. I'm just doing a preliminary investigation into what I call spatio-temporal moments, which I've kind of just using as the basis for trying to understand how the universe came to be and various behaviors that we associate with things such as light and such things such as matter. And my basic concept is to start very, very simple, with as little mathematics as possible, to become more complex over time in investigation, primarily using my imagination, because I am not into studying deeply into what other people have already dug up about these things. For instance, I just read a little wiki article on gauge theory. And you expect when you read anything online, Wikipedia for instance, that somebody will start very simple. Because I was going to choose the word gauge to describe what I'm going to, these images behind you and their relationship to energy and ultimately to mass. And what I wanted to use the word gauge for is to say that it's not dimensious. None of this is dimensionless in terms of not existing in space and in time, but it's dimensionless in terms of not having to have any specific dimensionality to it. In other words, it can expand or contract. It can become higher vibrationally or lesser so, all depending upon its neighborhood in space and the amount of energy that has been released into the environment. So let me just give you that as the basic preliminary. I don't know much about physics. I only have basic high school and college background in terms of physics and in terms of chemistry, in terms of energy, and in terms of matter, in terms of the construction of atoms being formed out of nucleonic particles such as a proton and a neutron. What you would expect of anyone who is reasonably background educated. But what I believe in is our ability to learn stuff by thinking about them on our own, investigating on our own, and developing our use of our creative imagination in order to better understand the world around us. And but I do have a fairly reasonable background in astronomy, but largely as an amateur astronomer. So I can begin with that as a basis for scientific thought. But fundamentally, I would say the purpose of science is to characterize the world, its properties, its behaviors, and arrive at fundamental hypotheses with regard to the nature of the characterized phenomena, and then, based on either a priori projections about the future that will be learned about it, or based on scientific experimentation or the gathering of more data through the use of instrumentality and the senses and other types of ways of gathering information about the universe, arrive at a fundamental theory that seems to hold up pretty well. But I will tell you one thing about theories. They are bound to be overturned in terms of future understanding and characterizations. So having given you that basic background in what I'm about to speak about, let's move on. Okay, I'm going to use a fixed camera. You may or may not see much of me, but hopefully you'll be able to see the board. What I've done is I've been sketching some of my notions. My basic fundamental notion is that this thing called a spatio-temporal moment always existed, will always exist. However, they are activated by the presence of energy. Now, I don't want you to think of energy as being photons. Photons are simply the way that these fundamental moments in space and time, according to my theory, deal with energy. In other words, these fellows here are disturbed by something which we call energy, but is typically measured in terms of the wavelengths of light. So we know the amount of disturbance in the universe, how we see, what we hear, various other ways of gathering information based on the fact that energy is somehow communicated to us through our instruments. And that communication occurs by way of spatio-temporal moments. Now, I don't want to give you any impression that what I have up here is the final answer to this problem of spatio-temporal momentarity. What I want to do is I want to just begin some fundamental concepts, which ultimately, these sheets of paper here may be completely torn up, but they were a beginning of an attempt to characterize how something we know not what got transmitted through space over time to be detected by our instruments, and particularly for myself as an amateur astronomer in terms of dark nebulae, which block light, reflective nebulae, which basically just take light from other sources and act like mirrors to reflect it back into space, emissive nebulae, which are actually atomic structures and molecules that have been disturbed in their ionic structure by the absorbing and re-emitting what we call photons. And then the very generators of those photons themselves, which is the nucleosynthesis going on within stars that is later translated through vast areas of substance until they finally leap off the photosphere of stars and head off into space to create emissive light from emissive nebulae, reflected light from reflected nebulae, or are being absorbed by cold dark matter, heating them up over time, potentially to the point where they are basically giving off infrared rays, but eventually causes enough turbulence so cold dark matter within the fabric of space itself will begin to condense through turbulence to form the beginnings of bodies, which could be as small as a tiny speck of a meteor or as large as the most massive stars of 20 to 30 times the mass of our own sun. So that gives you an idea of perspective, but every bit of it is somehow communicated through my speculative essence, which I call a spatio-temporal moment. Now let's have a look at my first model of a spatio-temporal moment. All of this stuff is hand-drawn, but it's based on assuming that the maximum excursion of a spatio-temporal moment is the number 4. So it has a radius from the point of origin all the way to its extreme location, extension away from this nucleus as a kind of spiral as being a radius of 4. Now that's what I mean by a gauge theory. I'm simply saying we're going to gauge all this to the numeric value 4. And we're also going to gauge all this from the point of view of 4 being one extension into one phase relationship of 0 degrees all the way out potentially to the half-split notion between 180 degrees in terms of a full cycle, a half cycle of this spiral. So basically this dimension goes from 0 to 4 and then to 8, which is basically the same length as from our originating point 0 here to our final termination point 0 here. And I will explain more about this. So basically these numbers are just numerics. There is no real way of measuring that I'm aware of spatio-temporal moments in terms of their dimensionality, but they do have a dimensionality. Now I did mention this hypothesis to a friend, and he thought basically I was talking about some aspect of string theory. And in string theory, basically you have these dimensionless strings that somehow are, I believe, because I haven't studied it, somehow these strings are a way of connecting things up, kind of like wires, but they have no dimension in terms of their width. But they may have a dimension in space in terms of their length. And I said, no, I'm not really talking about string theory here. I'm not really big on multiple dimensionality. Really not. I don't think there needs to be 11 dimensions in space, but I do believe there has to be substances that are more and more subtle. In other words, the world we live in is made out of substances that are very, very crass. But there could be substances that are subtler and subtler and subtler, and that is the domain from which I believe that all of the spatio-temporal moments in the universe got disturbed when we had the Big Bang event. Something precipitated out of a subtler level, let there be light, and something caused all these moments to go crazy. Now, normally when these moments are agitated, they simply pass on whatever that disturbance is to their neighbors. I call it stressor theory. But to account for the existence of matter in the universe, we might hypothesize that these moments somehow can get entangled with one another and therefore get stuck. And when they get stuck, they may last only as long as they're being stimulated, and then fall apart again, or they may get stuck and last for extremely long periods of time, the best example of which is a proton, which I believe is composed in quantum chromodynamics, I believe that's what they call it, of an up and down quark. Now, these spatio-temporal moments could also create all the other types of quarks. I think there's 4 other flavors of them. But those quarks don't have enough stability so that once the tension that induces them to entangle can last. So they almost instantaneously dissolve back into spatio-temporal moments. But in addition to forming protons, through entanglement, which is going to require a combination of different kinds of forces all working at once in association with spatio-temporal moments, you also can create a thing called an electron. An electron is a light particle of matter, light meaning it's not very massive, I believe it's called a lepton, and protons are what are called bosons, heavy material substances. Now, you can't just have a universe that's composed of just protons and electrons. You could if all you wanted to have was hydrogen atoms, but in the presence of protons and in the presence of these entanglement principles, you can also result in neutrons. But neutrons only have, I believe, a half-life of about 15 minutes in free space. So neutrons that are entangled along with protons during their formation, and I think most of that entanglement, by the way, happens in stars. But it did happen in the course of the Big Bang because there were primordial atoms, nuclei of also helium, and I believe lithium was formed during the Big Bang. So neutrons were created, but they are only sustainable in the presence of protons, and those protons may or may not have to have electrons orbiting about them in orbital shells, which they don't really particles. They're like waves that go like this all around them. Waves, waves. Anyway, so that is the notion here. We're saying we have these, hypothetically, the primordial thing is spatio-temporal moments, which are a kind of spiral vibration that you're seeing here and here, longitudinally here and along the axis here, entering and exiting, and then over a period of time achieving a great deal of amplitude and then falling off again. And then this falling off occurs, as I will explain later, as this energy is transmitted to a neighboring spatio-temporal moment. Okay, so now I've mentioned a way in which this thing called energy can be transmitted. We detect them as photons, but really what they are the oscillations of spatio-temporal moments. Whatever disturbs them, however, is the cause of energy, not energy. Now, imagine that there is moments all around in space, everywhere. There just happens to be one that stimulates a moment right here. This is the entry side of a moment, right here. Okay? So there's another moment here which looks like this end of the waveform that is distributing, it's getting rid or de-stressing or getting rid of a hot potato of stress into a neighbor. And that neighbor begins to spin, all right? Not spin but to expand in terms of taking that energy and then trying to get rid of it by spiraling outward. And it doesn't matter which direction we go, but I just happen to do it here, all right? Now, that expansion is the absorption of stress from a neighboring spatio-temporal moment, stimulating this one, and that stimulation begins right here at the middle of the previous moment. And it gets rid of its energy by winding down until it once again achieves equilibrium right at this point here. But that occurs as this end, for instance, of another moment is beginning to absorb the related energy and expand out. Now don't think that there's any kind of real axis to these. Just think about in space that there's a possibility of a moment here and another moment there interacting, creating this oscillation, resulting in the transmission of energy, which in combination with all the other transmissions of energy creates what we call a wave in space. So the waves we're seeing in space are not these. The waves we're seeing in space is the conjunctive absorption and dissipation of energy. And that takes on kind of an organized form, which we call a waveform or a photon in space, which has a beginning and a middle and an end, moves through space. No movement is really occurring in space. It is only the stimulation of that energy that is being transmitted downstream. Photons don't move. They are simply being conveyed. And this was supposedly disproved by the Michelson-Morley experiment that there was an ether, but I don't really that when they posited this idea of an ether, that people understood that it was something other than matter that was being agitated. What I propose is being agitated are spatio-temporal moments. Okay, so a neighboring ST moment, whatever it looks like, you can think of it as a cloud, you can think of it as a waveform, you can think of it as a spiral or something, somehow gets a hot potato of stress energy from other part of the universe. That energy builds up and then it collapses again. And it not only builds up in a single moment, it also builds up across a bunch of moments. They're all trying to deal with the stress passing through them. Now, that makes sense for transmitting energy in terms of what we call a photon, which we can gather with the lenses of our telescopes or the mirrors, etc., where you can focalize so we can see a galaxy or a planet or the moon, whatever we want. Yes, that's what we call a photon, but that's really a moment. A bunch of moments, a batch of moments, all responding to energy. Now, the interesting thing is, we get that concept, right? That energy is transmitted by moments, which gives the appearance of photons because these moments want to get rid of the stimuli, the stress that has occurred to them. Now, all of that happens really, really fast, the speed of light. But I'll tell you something else. It's entirely possible the density of these moments varies through the universe. And because it varies, they all make contact with one another somehow, but the contact could be like an accordion spread out, or it could be like an accordion compressed, which changes the velocity of light as it moves through the universe. Keep in mind, I began to explore this notion, which was new to me, in a Mathematica Galactica, which I called the recessional velocity on this YouTube channel. Now we get to refer back to entanglement. How did matter come to be? Well, look, if you don't like stress, and it's coming at you fiercely, and you got to deal with it, one of the first things you want to do is fend it off. Well, how can you fend off all this stimulation coming at you? Well, you can't stay in a waveform like this, all right? What you want to do is what I call circle your wagons. You get together with a bunch of your buds, other moments, all in different states of agitation, and you co-entangle with them. You get all bound up. Once you get all bound up, you create a shield barrier around yourself. You have mass. So now instead of being buffeted by pure photons, the mass of you is being buffeted by the other moments that are agitated. And that creates kind of a shield around you, which changes the energy state from purely radiative to absorptive heat. And I tell you, these guys much prefer heat to pure radiation, because heat is a very slow oscillation, and it's all motion. So in this case, moments are actually they're no longer just in space vibrating. Now they are in space and time and can be moved around because they have mass, they have extension. Also, they begin to emit something we would call gravity, because these guys, however they've been programmed, they know that the more of them they have, the less shock they have to take on the part of photons. So now they want to attract other moments to themselves. Or you can just think of it as other moments say, hey, this is a great idea, I'm jumping in. So now you get the idea of attractive force of gravity. So when Einstein says space-time is curved, what he's really saying, according to this theory, is you got a bunch of spatio-temporal moments, and they are all circling the wagon, and they want to jump in too, which means one thing, that light itself, whatever is stimulating it, now is being refracted in some way, because these spatio-temporal moments are not just propagating on a straight line. Now they're gathering up into a mass, and therefore you would have curvature. So it is not space technically that is curved in terms of Einstein, but the actual spatio-temporal moments are now aligning themselves in such a way that the dissipation of force on the ones that are on the outside that are still ST moments are now being focalized into the mass body, so that all of these ST moments can somehow circle the wagon and protect themselves from the stress of whatever that source of energy is that we call photons, because that's what we see, but who knows what the actual source of that stress is. Now we know from terms of stellar production stars that you can squeeze matter together and you can literally get some of whatever that energy is out of atoms. So even though these guys circle the wagons and they're getting more and more massive and building up their mass and getting higher and higher densities, there's also another factor that's going on that can cause them to recombine themselves as elements, as particles within stars, so that some of that stress is radiated. And that's what we call nucleosynthesis. And the nucleosynthetic process can happen and actually release energy up until the mass of iron, when iron is created. But after iron, you actually draw in more energy than you give off through nucleosynthesis. And anybody with a spreadsheet can sit down and they can put in how many electrons and how many neutrons and how many protons are in an atom, and you can write in this. I have actually done this, where what the mass of each is, proton, neutrons, and electrons, and you can run a spreadsheet and you can have it added all up, and you will see that there's a delta between the total mass of a particular, let's say, iron atom, and what it would be if you just added up all the neutrons, protons, and electrons masses and the actual weight of the proton. And that's how you can determine where the breakage point is between emitting energy during fusion and then absorbing it during fusion. Now, I don't want to take too much more time on this, so I'm going to do a quick review. By way of review, what you see here are 3 hand-drawn sketches of what I consider to be the minimal concept of a spatio-temporal moment. You're looking at a spatio-temporal moment from the end here, where it is receiving some kind of stimulation from a neighbor. So we would call this the negative pole of the spatio-temporal moment, which would line up to some degree with the positive pole of a previous spatio-temporal moment. Notice this one is spiraling outward in this direction, and this one is spiraling inward in this direction. This is the positive pole where it's pushing whatever the stimulation is onto the next spatio-temporal moment, and the next one is receiving it like this, the negative. This is a profile view, and you should think of this as a spiral going and then going out the other end. And that's how the energy is dissipated. Absorption, high rate of change, getting more and more, the energy is moving more and more slowly as it covers more ground, and then dissipating as the energy, whatever that energy is dissipated out the other side. All right, so this is the negative end of a spatio-temporal moment. This is a longitudinal view in 3 dimensions, in 2, but a 3-dimensional spatio-temporal moment. This is the emissive end where the energy is finally being handed off to another moment. Now, this is a single moment in space, but in reality, it can get really wacko. And when it gets wacko with these moments, they can combine together to form particles. E equals mc squared. The energy is converted into mass. The amount of mass is equal to the velocity of light squared. And all you're doing is converting back and forth between mass and moments. When you convert all the moments out, it's pure energy. And when you absorb all the energy and you put it into the mass, you get a big morass of spatio-temporal moments that can be almost sustainably bound together through entanglement, or only briefly in the case of very evanescent subatomic particles that are created by particle generators and accelerators for hundreds of thousands of a second, nanoseconds. And then they just turn right back into pure energy again because the entanglement doesn't hold. So the only particles that sustainably manage to hold are electrons and protons, and neutrons in their presence of protons in the galactic nuclei. All right, so how does energy get what is energy? I don't know. How does it get transmitted? By spatio-temporal moments. How does matter come into being? Because these guys can create a really chaotic mess. What kind of chaos actually is sustainable? Only what we know in the universe right now. Protons and electrons and neutrons. Oh, by the way, why don't we have positive electrons? Because they instantly would be converted back into pure energy. So there is a bias in the universe. Maybe it has to do with somehow these spatio-temporal moments are aligned. Maybe it's their spiralicity. Maybe there's some dimensionality to it we do not understand. But whatever is these moments, beginning with, 1, they have always existed. 2, when something enters into the space in which these things exist, call it energy, these things propagate it to get rid of it as fast as possible. Stressor theory, light. 3, if you get a bunch of these all hyper-stimulated together, they will circle the wagons to create matter. 4, over time, once all the energy is abstracted and all the energy dissipates throughout the universe, it's entirely likely that even protons would eventually break down and become moments again, waiting for that Big Bang experience to set the whole thing off again. So anyway, I'm not claiming any of this is true. I happen to like the model, however, and it's a great way for me to learn how to conceptualize, and maybe I'll even get some mathematical skills together, and I'll share with you on a future Mathematica Galactica. Signing off, Carpe Diem, because today is the day.